Hello, everyone. This is Ryan Law. I'm the current chair of the ASG Technology Committee. I'd like to welcome you to another author series podcast for an upcoming technology review published by our committee. The ASG Technology Committee provides reviews of existing, new, or emerging endoscopic technologies that have an impact on the practice of GI endoscopy. To develop these reports, we use evidence-based methods with the Medline literature search to identify pertinent clinical studies on the topic and a manufacturer and user facility device experience database to search and identify reported adverse events of a given technology. Both are supplemented by accessing related articles featured on PubMed and by scrutinizing pertinent references cited by previously published studies. We aim for controlled clinical trials. However, in many cases, data from randomized trials are lacking in endoscopy. And in such cases, large case series, preliminary clinical studies, and even expert opinions are used. Technical data are gathered from traditional and web-based publications, proprietary publications, and informal communications with pertinent vendors. The technology status evaluation reports are then drafted by 1 to 2 members of the ASG Technology Committee and then reviewed and edited by the entire committee to ensure that we're publishing high quality documents. Today, I have the pleasure of being joined by Dr. Koushik K from Washington University in St. Louis, Dr. Dennis Chen from University of Chicago, who will talk about their upcoming paper on biliary and pancreatic ablation devices. This will be an upcoming manuscript published in gastrointestinal endoscopy in the coming months. And so I would like to welcome both of the lead authors, two people who are colleagues and friends, to join us for discussion today. Welcome, guys.
Thank you.
Thank you.
So we'll start off kind of with some just brief questions about the document. Well, ideally, I'm looking for input from both of you, but we'll start by directing and giving questions to one or the other, and we'll go from there. Starting with Koushik, why do you think this review was important for the ASG membership as well as for the patients that we take care of? What do you think it adds to our current endoscopic armamentarium?
I think that first, thank you to Ryan and for the to the ASG for the opportunity to participate in the organization and in this committee. I think that this document really is at the heart of kind of what the technology committee is about trying to do, is that there's a tremendous amount of innovation and publication and sometimes, moderate quality or low quality evidence for a variety of these different techniques that are reviewed in this document. That have that have the potential for significant clinical benefit, but I think are still under active investigation. And so allowing the readership and our membership to be able to kind of in an organized fashion understand what these technologies are, what they're not, the differences between them, where they've been applied and where they haven't, and what the data is for their utilization, I think will really help people, be able to approach this technology with a greater poise than they would otherwise.
Thanks, Koushik. So Dennis, I'm going to leave it to you to kind of, I want you to summarize here in a little kind of section on what's the meat of the paper? What's the technology and the types of devices that are focused on, I shouldn't say just devices, techniques even, that are focused on within this paper that you think is imperative for people to pay attention to and decide if they can incorporate it or advance it within their own practice?
Yeah, so I think what we really try to focus on is the variety of different ablation devices that are available for use through the ERCP and through the EUS scopes. And, these are, I think, devices, as Koushik said, that are increasingly available and increasingly used. I don't think they're really ready for prime time, but I think certainly at a lot of tertiary referral centers, these devices are being used. And we thought it was important for this paper, this publication to be written so that folks who are using it have a resource to go to look at the devices that are available, the techniques for using them, as well as some of the data that's available about efficacy, safety, and all those things. And so we really divided the manuscript into ERCP catheter devices and then EUS catheter devices with the radiofrequency ablation devices, as well as the brachytherapy, as well as the photodynamic therapy. I think those are the three big categories of devices that we had. And then we further broke it down into the situations and clinical scenarios where they may be used, whether it's pancreatic cancer, whether it is intraductal cholangiocarcinoma, pancreatic cysts, and so on.
All right. And I think that that's one of the strengths reading this document throughout its kind of growth and change. I think that's one of the strongest aspects of this particular paper is the inclusion of when to use each type of therapy and in what settings. And why why we need these types of devices, both within the biliary tree or through an EUS platform. I think you guys spelled that out quite nicely. I like including the clinical scenarios. In terms of the current technologies, you mentioned that we have two radio frequency ablation catheters for ERCP and one, to my knowledge, one EUS platform. Koushik, where do you foresee the growth in this space kind of in the coming years?
Yeah, I mean, I think there was a lot of movement even in the time frame that Dennis and I were working on this document with what was actually available on the market and varying, we tried to kind of we tried to be comprehensive in what we reviewed, acknowledging that certain things, may not be available, at that moment. So, for example, the Habib catheter, the ERCP based biliary Habib catheter not being available, as well as I should say, sorry, I take that back. The Habib EUS based catheter not being available, and the alert that came from the FDA regarding the utilization of certain generators with the biliary catheter. I think it's a very dynamic field. As we were writing this document, there was a fairly sizable, important study by Jarasova et al. That came out in Gut, last year, or I think in the last 12 months, that actually tried to do high quality, randomized analysis of the utilization of patients with cholangiocarcinoma or pancreatic cancer with or without RFA, utilizing the Habib endobiliary probe. And interestingly, and perhaps disappointingly, they found no real difference in median survival between these two groups. 10.5 months for cholangio versus 10.6 months, and 5.4 months for pancreas cancer versus 7.7 months. And not much difference in terms of stent patency either. And they actually had to terminate the study because of futility by their DSMB. That study, to me, and how that came out in the midst of us kind of putting this out, really kind of demonstrated to me that we have a lot of strong case reports, case series, single center series, single endoscopist experience, institutional experience. But that's the sort of study I think we're waiting to see in this space to really help us figure out, are these devices and is this technology going to be game changing, for these patients with these very difficult, admittedly very difficult, problems, to solve.
Yeah, and I think you raise up a very, very good point about the current literature that we have to scrutinize. Unfortunately, may not be super favorable for using these devices at present, but that doesn't mean that there's not a role. And I also think that some of that may be a function of we're just not using it the right way. Maybe there's newer devices that can optimize different types of energy for greater benefit. But it's been quite underwhelming, I have to say, when going through the literature. And I think that's the part to figure out, because in theory, this all should provide more benefit than I think we're seeing. So I think it will be interesting to see how comparable devices or new routes of energy, whether it be pulse electrical field or microwave, or who knows what will be the next kind of big thing in this space, but how that changes. Not to kind of digress, but one other kind of important thing that I think is mentioned in this paper that I wanted to touch on with Dennis was the use of EUS ablation with chemical ablation. This is another area that I think over the years we have continued to hope that we would see additional benefit. Um, but really, most of the data is kind of centered around a few institutions and the data they produce. Dennis, do you think that we'll start to see an expanding role with chemical ablation of cystic lesions or even solid tumors with chemotherapeutics in the future? Or do you think this is something that's probably on its way out?
I think there's still, I think, potential and excitement and interest in developing these devices and looking for the proper role for it. We've seen some promise for chemical ablation of pancreatic cysts as a treatment option, but really the high quality evidence in large population studies are really lacking. The biggest randomized trial was the CHARM trial in 2017, and while it's commendable to put together a randomized trial for it, there were only 39 patients in this trial, and that's to date one of the largest studies that we have available. And when they looked at systematic reviews, and they reviewed 8 studies, I believe they had a total N, I think, of 114 patients across 8 studies. And so I think that's some of the limitation there. And there's such heterogeneity right now in the techniques of what chemical is being used for ablation that it's hard to pull together and really say what is the right way to move forward. But I think there's still a lot of potential in this realm.
I think that they're definitely, the researchers, primarily focusing out of Penn State, Hershey, and IU, have tried to continue with this and be thoughtful and create NIH funded now large multi-center study that's currently ongoing, which will hopefully eclipse the CHARM trial, to get enough patients to report something about it. I think what they've moved away from is the installation of ethanol, which I think we can all have all kind of learned, at least in the cystic space, increases the risk of pancreatitis and pain, and is probably not all that efficacious, and moved towards chemotherapeutics like paclitaxel. And I think they've also are coalescing around a selection criteria of which patients, would be appropriate, for this, kind of agnostic to the future of surgery, as opposed to, say, for example, solid lesions, which are also sometimes, put into our space as interventional endoscopists because the patient is not a surgical candidate, like a non-surgical candidate with a functional net. Which would be kind of the traditional thing that we're thinking in the world of solid lesions that we're trying to ablate with chemicals. There are some other like fundamental biology questions that kind of come into play with cystic lesions because, in US cohorts, about 20% of cystic patients with pancreatic cysts will develop a concurrent solid malignancy separate from their actual cancer. In Japanese cohorts, that can be more than 40% of patient population. So long-term studies are really kind of needed to figure out whether ablating this cyst addresses the overall field defect that's kind of occurring in these patients globally, or are you kind of playing whack-a-mole of a different kind? I think the real goal and dream would be if you would be able to ablate a patient's cyst and then discharge them from follow-up or let them go on their merry way. If you ablate their cyst and then continue to have to survey them the exact same way that you were surveying them before you ablated their cyst, it's not fully clear what the marginal benefit is for the practitioner or the patient.
Yeah, I agree. And I think what you touched on maybe where the next kind of phase for many of these technologies and techniques going forward is patient selection. Like, what patients do we capture? And maybe trying to take on, trying to apply a technology to the wrong disease state or the wrong patient, it never works out. I mean, we've seen that time and time again with a variety of technologies in medicine, and this would be no different. So I think finding the patients which we can help is critical going forward, and then figuring out how best we can help them and what agents to use for chemical ablation and so forth. So I'll start with you on this one, Koushik. When you look at this paper, what do you think are the top kind of 2 or 3 takeaways that our readership should get when they look at this manuscript?
I think one of the things is that of these technologies, RFA, which probably the current generation of interventional endoscopists have the greatest familiarity with, just because of its overwhelming success and clinical efficacy in Barrett's and esophageal related disease. Um, is probably one of the most mature of these approaches, and the most probably accessible to most people, as things like intraluminal brachytherapy, or PDT, still really have their niches where they're very popular in the country, but really require a tremendous amount of institutional expertise that makes the broad application of those technologies quite difficult. So focusing within the world of RFA, which is probably what most people are going to be having access to. What's interesting is that one of the greatest strengths of RFA as a technology in the esophageal space has been its dosimetry, why it has such superiority in so many ways over, say, for example, all the different cryoablation platforms, is that you step on that pedal, two scrape two or three, depending on where you're at, that you're going to have a certain depth of penetration for 12 joules or 10 joules or however much you're utilizing. But that dosimetry is really an issue. If you look at table one of the paper that we put together, Dennis and I kind of tried to go together and pull every single one of the RFA papers out, and we tried to kind of very clearly lay out as best we could kind of surmise what the watts that were utilized, what the device that was utilized, and what the time of burn that was utilized, how long the time in between the burns, how many burns were they totally doing. And it really reads more like a paper from a decade ago talking about cryo of the esophagus than it really does of RFA, right? And so this like lack of consistency in dosimetry may be part of the reason why you might see a lot of efficacy in some studies and not a lot of efficacy in studies, and also then why it becomes very difficult to do reproducibility, and also then why it's difficult to combine meta-analyses. The other thing is there's a certain homogeneity of something like Barrett's esophagus. Obviously there's differences and such. But there's exquisite differences in patients with different types of bismuth 3, bismuth 4 strictures. What the ducts are accessed or not accessed. What pre-stenting, pre-RFA, what size stent you're able to get into, and so as a result, that's really going to affect our ability to kind of lump things together and treat all bismuth 3s in a certain way or all bismuth 4s in a certain way. The other thing I'll say is that there's also been somewhat of a very positive change in the world of the treatment of cholangiocarcinoma in the last 3 to 5 years, with the introduction of targeted therapeutics like Darva and so many others, and then things that are obviously on trial. Those patients have other options too in their chemotherapeutics that may be complementary to RFA or to these other technologies in ways that we may not fully appreciate or realize yet. As there's been a bunch of papers coming out talking about how RFA changes the tumor microenvironment or changes the particular antigen presenting cells, T cells, that are in that specific area after treatment. So there's some hope too that in combinatorially with what's going on in the med-onc world, we may be able to make some headway.
Thanks, Koushik. Dennis, anything you want to add in terms of main takeaways or things that you felt are key learning issues for this manuscript?
Yeah, I think, everything Koushik said was very well said and very appropriate. I think from a broader picture for me, what I hope folks take away is I think for our general readership, especially folks who may or may not be advanced endoscopists who are out in the community like that, I hope that this document can kind of serve as a reminder for those patients that they come across with these diseases that, there are these resources that are out there, and that this is available technology, and it may not be offered while at their own institution, but that, these resources and techniques are available for patients that are appropriately and thoughtfully selected. And then I think similarly for the folks who are at those referral centers, we hope this can be a helpful resource to refer to whether it's a refresher, a reminder, or hopefully, or whether it's new information, to look at this and see what people have been doing for these disease processes. And again, one of the big things is the challenge of it is these patients are rare. These diseases are infrequent, and then there's a lot of heterogeneity in what's been done. So we're hoping that what we've done here is pull together the information that's out there and provide a resource for the practitioners who may be using it.
Well said. Well, I would like to sincerely thank both of you for the amount of effort you put into making this a high quality document. I really appreciate it. And I know the ASG does as well. So with that, everybody should go to keep an eye on the table of contents for upcoming GIE journals that come out in the coming months. You'll likely see this document within there. Thanks again to Dennis Chen and Koushik K for their time contributing to this podcast. I appreciate it, and thanks again for the document. Good work.
Thanks, Ryan.
Thank you very much.